And so as it turns out, the infrared radiation, IR energy, is of the right energy of vibrational energy. Okay, so this the ability to move, to stretch, or to bend, that takes energy to move or stretch or bend, and that energy for small molecules is on the order of the energy associated with infrared radiation. Okay, so vibrational energy and infrared radiation are on the same scale. And so what happens then is these stretches and bends occur at certain energy, precise energy, and they're unique for different bonds and different molecules. Okay, so further, the infrared radiation, remember, it's electromagnetic radiation, and electromagnetic radiation is this movement of energy where you have oscillating electric and magnetic fields. Okay, and so that's the form of the energy. And since atoms are made of positive charge and negative charge, and there's a movement of the electrons within the atom, and there's an electric field associated with the positive charge and negative charge, there's an electric field associated with atoms, and there's an electric field that's different when you have atoms chemically bound. And so the electric field associated with the vibrational energy is what's going to be modifying the distance between the atoms. And that's a little bit complicated for us, but I think you should take my word for it that the electromagnetic radiation is affecting the electric fields and the magnetic fields associated with those electric fields. And it has to be precisely the same energy of the vibration in order to be absorbed. All right? And further, the vibrational infrared radiation is only going to be, the infrared radiation is only going to be absorbed in the form of a vibration, either a stretching or bend, if the overall dispersion of the electrons throughout the molecule changes with the bend or the stretch. Okay? And so, as it turns out, this type of a stretch and these two types of bends cause a change in the overall distribution of the electrons of the molecule. Think about it. If the molecule is static, you have electrons distributed around the various atoms and clustered between the two atoms. If you squeeze this side together and stretch this side out, you're changing the overall electron distribution. If you pull these atoms apart and change the bond angle, you're changing the overall distribution. But in this type of a stretch, this is called a symmetric stretch, the overall distribution is going to cancel out, and there's no change in the electron distribution in this type of symmetric stretch. Okay, so the result is that this type of motion absorbs infrared radiation, this type of motion absorbs infrared radiation, and this type of motion absorbs infrared radiation. So only molecules that are capable of undergoing the types of bends and stretches that change the overall electron distribution of the molecule are going to be capable of absorbing infrared radiation, and those are the ones that we're going to call greenhouse gases, because they can absorb the radiation.